Hey everybody, welcome back. Happy New Year. We're going to jump in and finish up chapter 3 and let's get started. So today we're going to be talking about inverse functions, and today students will be able to find inverse functions so that you can convert temperatures from Fahrenheit to Celsius as one example. So remember that a relation is pairing input values with output values. Usually we call this X and Y, where X is the input and Y is the output, traditionally. So an inverse relation interchanges the input and the output values. Basically, they're going to switch the X and the Y values and swap them. So let's say, take this for example, if we originally had this input and output value X and Y, to get the inverse of that, we're going to switch these. So X was 1, Y was 2, but now we're going to switch them so that X is 2 and Y is 1. So we're literally just taking those values of X and Y and switching them to find the inverse. All right, so let's take, if the original was input 3, output 4, the inverse is going to be input 4, output 3. And same thing here. If the original was input 5, output 6, we're going to now put input 6, output 5. So if I were to graph these and compare them, I know that my original, I'm going to put that in blue, was at 1, 2, 3, 4, and 5, 6. Whereas if I were to graph it the other way, we'd go 2, 1, 4, 3, and 6, 5. Do you see how they're slightly different if I were to compare them, right? They're actually inverses of each other, and what makes something an inverse is that it reflects over the line y equals x. So if this is my line y equals x, so whatever value of x is, it's equal to y. Whatever my original is a mirror image of itself over that line. So we'll keep looking at that in just a minute. Let's talk about this. Find the inverse relation of y equals 3x minus 5. So the first thing we're going to do to find this is step 1 is we're going to switch the x with the y. So I'm going to rewrite this as, instead of y, I'm going to put in x, and instead of x, I'm going to put in y, and everything else will stay the same. That was step 1. Step 2 is now we're going to solve for the new y, the one that we just found. So I'm going to get this y by itself. So I'm just going to move some things over. So I'm going to add the 5 over to get it to go away. So we're left with 3y equals x plus 5. Divide both sides by 3. And I end up with the new y equals x plus 5. But the last thing is step 3 is that the new y, we're going to call it the inverse, or f of the inverse, okay? So we can say, well, it's not really y, it's the inverse of y, and in this case, actually, instead of using f, we'll use the y, the inverse of y. So we say the inverse of y is x plus 5, okay? And if I were to graph those two things, to graph this here, I'd go negative 1, 2, 3, 4, 5. Slope is 1, 2, 3 over 1, and so on. It looks like that. But if I were to graph the inverse of it, I'd get x plus 5. So 1, 2, 3, 4, 5. That's going to go up 1 over 1. So if we see this, it looks like this. And what happens is if we look at that x equals y value, we're going to see that these actually are mirror image lines of each other. Okay, so here's what we know about inverse functions. We know that if the composition of f of g of x, which we talked about composition functions before, the composition of them, if it equals the value of x, and in the reverse, g of f of x also equals x, then, remember, this value of x is really important, then f and g are functions of each other. So this is really critical. X cannot be anything. This literally means the value of x. And this notation here, f, and some people would say to the negative 1, but it's not. We read this as f inverse. So when we see f inverse, that's what it means. So using that definition of inverse functions of each other, we're going to verify. When you see this word verify, you're going to come back up here and remind yourself of this definition of inverse functions. If f of x is 3x minus 5 and f of inverse of x is 1/3 x plus 5/3, make sure they're inverse functions of each other. So that means by this definition up here, we're going to find the compositions of each other. So first, we're going to find the f of the inverse function of x, which remember when we did this, we wrote the outside function first, so 3x minus 5, but we put the inside function into that value of x. So we're going to put that here, 1/3 x plus 5/3. And we're going to solve that. So I'm going to distribute here. 1/3 times 3 is really just 1x. 3 times 5/3 is 5. Bring down the minus 5, and we get x. Woohoo! So that's the first part of that definition we have done. Let's do the second part. So that means we're going to find what we had in here, f of inverse, or f inverse of f of x. So again, we're going to write our outside function first, which they said here was 1/3 x plus 5/3. But instead of that x, remember, we're going to put in this instead. So 3x minus 5. Now we're going to distribute. 1/3 of 3x is just x. 1/3 of negative 5 is minus 5/3. Bring down the plus 5/3. And look, these are going to cancel. So do you see how we get x for both? So we just showed and verified that f and inverse f are indeed inverses of each other. And remember too, f of x is often referred to as y and vice versa. Okay, so here are your inverse basics. Step 1, to find the inverse, we switch the x and y. Step 2, we're going to solve for the new y. And step 3, we'll rename the new y as f of inverse. So let's look at this one. If I was going to find the inverse f given this, I'm going to use my steps. So first we're going to switch. Remember, f of x is another way of saying y. So I'm going to write that first. Now I'm going to switch the x and the y. So we're going to switch the x and the y. So I'm going to rewrite this as x equals y squared. Step 2, we're going to solve for the new y, meaning get it by itself. So we're going to take the square root of both sides, remember plus or minus, and that will cancel here. So I end up with y equals plus or minus the square root of x. But remember, we're going to step 3, rename the new y as the inverse of f. So this instead of y, this is really inverse f equals the plus or minus square root of x. Now keep in mind, if we're looking for the inverse, remember back here it said x has to be greater than 0, meaning positive. So when we come back here, we can kind of revise our solution that it doesn't have to be plus or minus, it's just the positive part. So it's just the positive root of x. And that's your answer. This is your f of inverse of x. And then lastly, our horizontal line test. So remember, a vertical line test, when we did that way back in the day, would test to see if f was a function. So let's just say here was my graph. If I did my vertical line test, I'd say, yeah, that's a function. A horizontal line test, the inverse of f is also a function if the graph of f passes the horizontal line test. So we're going to do it the same way, but instead of drawing a vertical line, we're drawing a horizontal line. So horizontal line here only passes once. This passes, which means this, or I should say the inverse of this is also a function. So if this is f, f and the inverse of f are both functions. But if I do the horizontal line test here, it does not pass. So we say only f is a function. The inverse of f is not a function. Okay? All right, I'll see you back in class.